and welcome to lesson 2 of week 4. In this lesson, we are going to look at transactions in MySQL. My name is Mildred. In MySQL, we use transaction to perform a sequential group of operations or queries that we want to perform as a single unit. Now, using the secular database, we will not really have an example that makes real-world sense. But let's assume that we are working with a banking application, for instance, and a customer wants to transfer money from their account to another customer's account. There is a chained sequence of events that must be executed together and should all be successful together or fail together. The sequence of events is like this. The customer will first have to select an amount to be transferred from their account to another customer account. In selecting an amount, the system checks the database to see if the customer's amount is greater than or equal to the amount to be transferred, and deducts this amount from the customer's account. When the deduction is done using an update statement, it now takes this money and inserts into the new account. Now, if the insert into the new account fails, we want all transactions to be cancelled. Most importantly, the deduction from the customer's account. We use transactions in MySQL to perform a group of queries that must succeed or fail together. Transaction keeps to the ACID properties, and ACID stands for atomicity, consistency, isolation, and durability. And as we go more advanced, we are going to see how to keep to all of these properties. But one of the properties we are going to be looking at strictly is the atomicity property, which ensures that all statements in a chained unit of events will be successful and execute a commit statement, fails and execute a rollback statement, and then we're going to look at the auto commit setting, or we are going to also look at the operational data from the information schema, but we are going to focus on the commit and the rollback statement in these transactions. For this lesson, let us illustrate transactions using the inventory and the rental tables. So let's see what the inventory table holds. So let's select all from inventory. So we have an inventory ID, a film ID, a store ID, and the last update. And let's select from the rental table. We have the rental ID, rental date, inventory ID, customer ID, and so on. So both the rental and the inventory table has an inventory ID column, which means that inventory ID on the rental table must be a foreign key of that of the inventory table. So let's say we want to insert a rental into the rental table. We want the inventory to be inserted first, and we want the last inventory to be the next inventory for the rental ID or for the inventory insert. This is how we write our queries to keep to transactions. By default, everything we do is committed in MySQL, and we don't want auto commit to take effect when we use transactions. So we want to set auto commit like this. So we use the statement set auto commit first, and we're going to set auto commit to either we use 0 or we use off. And anytime you want to turn it back on, you put on or 1. So I'm going to say set auto commit to 0 like this. So no transaction should be committed until it meets a commit statement after all the change events have been executed successfully. So when we set auto commit to 0, it means that our changes are not committed automatically, and then we want to start transaction. So we use the start transaction statement to start transaction. There are aliases for start transaction like begin or begin work, written begin like this, or we use begin work like this. So there are aliases of start transaction. So let's use start transaction. So we start transaction like this. What we want to do is to select the inventory ID from the inventory table, add 1 to the ID to be the next inventory ID. We don't want to figure out what was the last inventory. We want this to be automated, and we're not using like the normal auto increment when we create tables, but we want to do a transaction where we want to chain 2 events together and make sure they either succeed together or fail together. When they succeed together, it should be committed and the changes should be permanent in the database. If it doesn't succeed together, then the changes should not be committed and it should be rolled back to its previous state. So we start transaction like this, and we want to look at the inventory table. So we say select, we want to give it a name, and we use the @ symbol like this. Let's give it the name inventory ID. So it's going to be the name of the new inventory ID that will be inserted. We use a colon and an equal to like this. We want this new inventory ID to be equal to the maximum of the inventory ID column. So let's say maximum of the inventory ID. And then we want to add 1 to that maximum. So it will be the next inventory ID. And we're selecting this from the inventory table like this. So we now have our next inventory ID that we want to insert. We're also going to do this for the rental table, and we want to get a rental ID that is the maximum of the rental ID and add 1 to be the next rental. So we'll say select and we'll give it a name to be rental ID like this, and we want it to be equal to the max of the rental ID column, and we want to add 1 to the max, and we're selecting this from rental. So we have our next inventory ID and our next rental ID. So it is time to now insert into the inventory ID the new inventory, and then use it as a foreign key to now insert into the rental table a new rental using that inventory ID that was generated. So let's use the insert statement. So insert, so we're inserting into inventory first. So we want, if it fails to insert into the rental, the insert into the inventory will be rolled back. So insert into inventory. What we are inserting into the inventory is an inventory ID. The columns we are inserting into are the inventory ID column, the film ID column, and the store ID column. And the values we are going to insert here are the inventory ID now will be the new or the next inventory ID that is auto created here. So it's going to be at inventory ID. So it should match this name here. So that's going to be the next inventory ID. And we want the film ID to be, let's say, film ID 2 and rental or store ID 1. So we've inserted this. And then we want to do the next insert into the rental table, and we're inserting into rental. And what we want to insert into are the rental ID columns. We want to insert into the rental date column. We want to insert into the, let me spell rental correctly. We want to insert into the inventory ID column. We want to insert into the customer ID and the staff ID column like this. The values we want to insert here are the rental ID now is going to use the automatically created next rental ID that we defined up here. So it will be at rental ID. We want to put the rental date to be now, to be the timestamp of now, and we have a function for that now in MySQL. And then we also want to use the inventory ID, so one of the next created inventory ID like this, and then we want to use, let's say we want customer ID 36 and staff ID 1 like this. So once this is done, these changes will happen, but it will not be committed until it sees a commit statement like this, which means make the changes permanent when all of this succeeds. If this doesn't succeed, it's not going to be permanent. Let's go over this before we run this. The first thing we want to do, because MySQL by default makes commits set auto commits to true by default, which means that everything is auto committed. We do not want that effect. We want the transactions to all go through, or the chain unit of events to all go through before it is committed permanently, or it should halt and roll back the transaction. So we set auto commit to 0, then we start a transaction. We want to get the last inventory ID, and we use the max function to get the maximum inventory ID, add 1 to it to be the next inventory ID. We do the same for the rental ID, and we insert into the inventory table because inventory is a foreign key, or inventory ID is a foreign key to the rental table. We are going to look at foreign keys as we go along, but for now we know it is chained. Whatever is in the inventory ID column is what is going to be used to populate the rental ID column. Because it is a foreign key, we cannot insert an inventory ID into the rental table that does not exist in the inventory table. And so we insert into the inventory table an inventory ID, which is the next inventory ID that is auto created based on this statement. We insert a film ID and the store ID, and then we go into the rental table and insert the rental ID based on the next rental ID, the date based on the timestamp of the current moment the transaction is taking place, the inventory ID, which is the next inventory ID that matches this, the customer ID, and the staff ID. And then if all of this is successful, then we want to commit, which means make the changes permanent. And then when I run this, if it's all successful, we get everything, one row affected and commit statements all in green down here. Now we have done this. Let's check the inventory table and then check the rental table and see if we can find this newly inserted stuff there. So for the rental, we have a customer ID of 36. For the inventory, let's check the store ID of 1 to see what we have done there. So I'm going to remove this and I'm going to say select all from inventory where store ID equal to 1. And then we'll see there is this 4582 inventory ID, and this is the data we just inserted, and it was updated on the 6th of May 2023 with the timestamp there because we use now. So we can find the row we inserted, and this is the inventory ID 4582. So let's check the rental table. So select rental, select all from rental where inventory ID is equal to, let's use that inventory ID, and we return that. So this is the rental ID 1650. We just rented the movie at the timestamp, and we have the inventory ID to match the inventory on the inventory table. We did that for customer ID 36 and the staff ID was 1, and the last updated was still the same time that we inserted onto the record. So we can see that the record we inserted is there committed in the database. So let's illustrate rollback. Let's say I want to clear this new insert. I don't want it on the table anymore, and I come and I say set auto commit equal to 0. Now I want to delete from rental where the inventory ID is this. When I do this, it is going to be successful. It is going to be successful, and this row is deleted. But remember, it has not been committed, so it is not permanent. When I say delete from inventory also, where the inventory ID is this, it will tell us it is successful, it has been deleted. But when I start a new section, for instance, so let's copy this inventory ID. Let's say I want to do a new connection. Let's connect to a different place. Let's say to training. So I connect to a new place and I try to select all from inventory. So let's use Sequential, where inventory ID is equal to this. I'm going to get that record displayed, which means it was not deleted. Why didn't we get it deleted? Because we did not commit the changes. So I can go back to that and use a statement rollback like this, and it will roll back that changes. So which means that the delete that happened on that section was not committed, so it is not made permanent in the database. So we can roll it back so that that particular session will still have this, but because it is not committed, all other sessions can still find the data. So which means that the changes have not been made permanent. So I want you to explore, to try this out, to try to make sense of it and try it across tables to create scenarios. That is the only way you can understand transactions, commits, and rollback in MySQL. So this is where we end this lesson. Thank you and see you in the next lesson.